All right, we're going to do 16, 19, and 21 today. Aren't you excited? I can see in your eyes, you're all like, no, don't do it. But anyway, so we're going to divide each side by 4 here, like we said a minute ago, and I forgot to turn on my recording. And we get 3/4, and then to get rid of a square, we must square root each side. So I'm going to square root this side. I'm going to come over here and square root this side, and you must remember to put a plus or minus in front of a radical when you're doing a square root of a number. So over here, we got sine x because the square root and the square cancel out. Over here, you got the square root of 3 doesn't simplify, so we got plus or minus square root of 3. But on the bottom, the square root of 4 does simplify to 2. So when you're doing this, first thing you want to imagine is there anywhere on the unit circle that you have radical 3 over 2? And the answer is yes, there's a bunch of places. All the 3060s have a radical 3 over 2, every one of them. So the next question we want to ask ourselves, is sine the y or the x when we're solving these? And everybody, what is it? Y. So this means we are looking on this unit circle where the y values in the ordered pairs are going to be radical 3 over 2 and negative radical 3 over 2. So something I want to tell you is, that I just said a minute ago before I filmed, radical 3 over 2 is always greater than a half. Okay, and you check on your calculator. So I'm looking for where the y values are higher. Well, I know they're highest up here, and up here, and down here, and down here. They're the lowest. So right here, this ordered pair is a half and radical 3 over 2, and that's at the 60-degree mark. Over here at the 120-degree mark, you have negative a half, but the y is still positive radical 3 over 2. Down here at this one, you got 240 degrees, where both of them are negative. And right here at 300 degrees, you got this. But what we're worried about is, from this thing over here, we're worried about where is the y radical 3 over 2. So if you look, the y values out of your ordered pairs at these 4 places are where you have radical 3 over 2s. So that tells me those are my answers for x right here. So x is going to be 60, 120, 240, and 300. And then we take those, and if you want to check them, you plug each one in there individually and make sure it equals 3. Do you want me to show you it works? Anybody want me to show you how to check it? Anybody? Just takes one of you. It doesn't take any no's. One hand goes up. I'm doing it. Okay. We're going to go on to number 19. Okay, we got 19 and 21 left. 19, I got a square again, right? So when I do this, I'm going to have the cosecant squared x equals 2. And again, there's a square there, so what do? Everybody. Square root, what I forget? Plus or minus goes right here. So that gives me that the cosecant of x is equal to a positive negative square root of 2. Now, I told you that when you get to one of these trig functions, either secant or cosecant, we want to change it to what? What do we use? The reciprocal. We want a sine or cosine. What's the reciprocal of cosecant? Sine. So that means that, and this is written over 1, right? So that means that the sine of x is equal to 1 over a positive negative radical 2. Now you have to rationalize radicals in this class. That means you can't have a radical in the bottom. So does anybody remember how to rationalize? Can anybody explain it to me? Or she needs to be wrong. Yeah. That's right. You take the radical part and you move it up to the top, and you take the radical or the number out of the radical on the bottom. I'm going to show you real quick why that works. What actually happened here is we're actually multiplying the top and the bottom by this. So what happens is, on the top, you got your positive, negative radical 2, and on the bottom, when you take a positive, negative radical 2 times a positive, negative radical 2, the radical 2, that's 2 of them, you can bring it out. And you don't have to put the plus or minus in the bottom because you've already got it taken care of up here. Okay? Now, the next question is, we just did a second ago, sine is which variable? So we're looking on the unit circle. Where is the y value? Radical 2 over 2, both positive and negative. So when you look on your unit circle, those are all of these places. They're all the 45-degree ones. So these are all the 45-degree angles. So those are all of my answers for x over here. Remember, on the 45, 45, 90s, both y and x are the same. That's why they're both radical 2 over here. Like this is radical 2 over 2 and radical 2 over 2. But the one we're worried about for this particular problem is the y one, because we're doing sine. Okay? So we got 135, we got 225, and we have 315. Question? Yeah.
More than likely, when you use the square root, you get out of 4 answers.
Usually. Not every time. Okay? But usually. Like let me give you an example real quick where it would not be that way. Like if it had sine squared x equaled 1, let's say. Okay, so if I square root 1, I got this, which is sine x equals positive or negative 1, because the square root of 1 is 1, right? So now it's asking, where are the places that y would equal positive 1 and negative 1? Now there's only 2 places. There's only 2 places. One, y equals positive 1 up here, and y equals negative 1 there. So this would be x equals 90 and 270. So it's not always 4. Okay? Anybody else got a question? All right, we got the last one to do. We're going to do number 21 here. Now, what I would do here, since that's a 4th root, okay, what I would do here is I'm going to, and we could have done that on these two. Well, this one not, but this one could have. But over here, I'm going to get this one equal to 0. So let me tell you, if I had a problem that looked like this, let's say I had a problem that looked like that. Okay? There's more than one way to do this. I'm going to show you 2 ways, okay? Because I want to make sure we get them both down. This is a polynomial, and you were supposed to learn in Algebra 1, whenever you had an x greater than 0, or exponent for an x greater than 0 is a polynomial. Okay? And you were supposed to learn that you take polynomials set them equal to 0 and factor them. Okay? This is called the difference of 2 squares. This is called the difference of 2 squares. So we can factor this to x squared plus 4 and x squared minus 4. Okay? Now is there anything in our class that we've ever learned to sum of 2 squares? To factor a sum of 2 squares? We ever learned that? The answer is no. So this stays x squared plus 4. But over here, this is still a difference of 2 squares. And this goes to x plus 2 and x minus 2 equals 0. Then we're supposed to take all of these and set them equal to 0. Just like I showed you the other day, the first day we did these on Monday. So over here, you subtract 4 over. And now we square root each side. What do you get for this? What kind of number is this? It's Mr. Downing's friends. Yeah. Mr. Downing just had a birthday 2 days ago. Had a party of 1. So that would be I. So where would these be on the unit circle? Or in real world, where would they be? They're not, so we don't have to worry about finding any angles for those. Imaginary aren't there. Okay? Then this would be x equals negative 2, and this would be x equals 2, right? Okay, another way to do this is, if I have x to the 4th equals 16, how do I get rid of a power of 4? And by the way I just did that, did you see I had 4 answers? Everybody see I had 4 answers? I had plus, minus 2i, I had 2, and I had negative 2. Did you see that power is 4? That means I'm supposed to have 4 answers. There's your 4 answers. What I'm about to show you is going to get rid of the imaginary ones aren't going to be there. So if you're having to find imaginary answers in college, you have to factor. If not, you can do what I'm about to show you right now. So you ready? All right, so how do you get rid of a 4? A 4th power. We did a 3rd power yesterday. What do we do to get rid of the 3rd power? Huh? Cube rooted. What are we going to do to get rid of a 4th power? 4th root. So this is going to be x, and you got to put, whenever you have an even, you got to put a plus or minus in front. You do not have to do that if it's an odd power. We talked about that yesterday. If there's a negative, you can bring the negative stays with it when it's odd. If it's even power, you don't have to do anything. So what you're supposed to do here, is you're supposed to break 16 down into prime factorization. In other words, I'm doing this thing. But you got a plus minus in front, and you got the 4th power, and you got 2 times 2 times 2 times 2. What's that 4 tell me to bring stuff out? What's the 4 root mean? The 4th root. What's the 4 tell me I have to take anything out? I gotta have 4 of them the same, right? But now it says I need 4 the same. Don't I have 4 the same here? So that means I get to bring 1, 2 out, and I get plus minus 2. So do you see that that gives me the 2 real zeros? You see it? It doesn't give me the imaginary one. So when you go to college, if you're doing imaginary, you have to know how to factor. How many of you are thumbs up? Because a lot of you are staring at the green and purple bug, and it just annoys me to death. 3 days in a row, and you're already shot, huh? Can't take it. So we do this thing the same way. So I could have subtracted this over and got 0 and done the factoring and all that good stuff. I could have done that. Okay? But what I'm going to do is I'm going to do this method because it's a little bit faster to do the 4th root. Okay? Actually, I'm going to factor because cotangent can be, no, it's not. I'm going to do it the fastest way. So for the same reasoning, when I take the 4th root of cotangent over here, I take 4th root of cotangent to the 4th power, and I take the 4th root of this one over here, which you got to put plus or minus, and this is an even root. I'm going to get the cotangent of x is going to equal positive negative 2 from all this same stuff I did. How many are thumbs up? Come on, I'm almost done. You in there, man? Okay, so cotangent and tangent, I told you to make what? Triangles. So we got this, right? Does anybody remember what cotangent is in terms of x, y, and r? Anybody remember? What's tangent in terms of x, y, and r? Y over x. So that means cotangent would be, so we are looking where this is x and where this is y. Now this is not the unit circle, just so you know. So where is x positive 2? Okay, where is x positive 2 and y positive 1? Where would that be? Quadrant 1. So that means I have a triangle in quadrant 1. Oops, come on. Where they're both positive. X is 2, y is 1. You okay? Where is x negative and y positive? Huh? Okay, we're gonna get this away. Where's x negative and y positive? Quadrant 2. So it works over here, where this is negative 2 over 1. Now we talked about this the other day. You can take this negative and you can have it down here. You can put both these down here like this, right? can move fractions where they are. So if I put, remember, the answer is positive, negative 2 are my two possibilities, right? So if I made both these negative, is that one of these answers? If I made both these negative, what's negative 2 divided by negative 1? Positive 2. Is that one of these answers we found that could be? It is, isn't it? So that means I can do it where both these are negative as well. So that means there's another one that works down here in quadrant 3. And if I make that top one positive and this bottom one negative, does that equal one of those two? Yeah. So we also have one down here in the quadrant 4. So there are 4 different triangles that work. Now, if I do Pythagorean theorem, I'm going to move these negative 2's above the x, or closer. I'm going to make them smaller. That's the x value. This is the x value. Now, if you want, you can do Pythagorean theorem, which says x squared plus y squared equals hypotenuse squared, which is r squared in here. And you don't have to do this. You can, well, yeah, you probably should. You get 2 squared plus 1 squared equals r squared. 5 equals r squared, so your r's are radical 5. What that means is every one of these is radical 5. Now, you really don't have to do this on this particular problem, but sometimes you do. That's what I'm showing you. All of those are radical 5s. What this tells me is every one of these triangles, they're similar triangles. Does anybody remember from geometry about similar triangles? Corresponding angles are what? Congruent. Right? So I need to find the reference angles. This is where I should have probably done it different yesterday because I did a negative. So what I need to do now, you know what I'm going to do is I'm going to take this thing right here because I don't have a cotangent button, do I? I'm going to rewrite it as tangent x equals 1/2 because I do have a tangent button on my calculator. And I could have done all of the tangents over here. These are the same 4 triangles for this. And then I'm going to remember what I did to get rid of the, I can't remember what the trig function was. How do I get rid of tangent? I do inverse tangent. So that means I got to come over here and do the inverse of 1/2. So over here I got angle x is going to be, and there is no place where your x over y is 1/2. There is no place. Even though half's on the unit circle, that's where the x and y's are 1/2, not x over y. You see a difference there? So I got to take out my trusty calculator. So get your calculator out. Make sure you can do this. This is the hardest thing in this section. So I'm going to type that inverse tangent. Now, I think my mode's in radians now because I did calculus. So make sure you're in degrees. Yes.
Why did you put the inverse?
Okay. The question is, if you didn't hear it, the question was, why did I put the inverse of tangent? Right? My goal is to solve for what variable in this equation right here? X. So I've got to get rid of tangent. I got to get rid of this because all I want is the angle x. So to get rid of tangent, inverse tangent and tangent cancel each other out. Just like up there when I did the 4th root of a power of 4, they cancel each other out. They're inverses. Just like adding 2 and subtracting 2 are inverses. The inverse operation of tangent is inverse tangent. Is that good enough? Okay. So I'm going to come over here and I'm going to say second tangent, and I'm going to type in 1 divided by 2, or you could type in 0.5 if you wish. I'm going to hit enter. There's the angle. That is my reference angle. That angle is really important. Okay, really important. But I'm supposed to round these to the nearest minute. So I got to hit what? Second, apps, 4. And I hit enter. Now I round that number. So I look at the seconds, the 54. You see the 54 seconds? I take those seconds, and does that round that 33 to a 34 or keep it 33? Goes to 34. What number does this have to be to round it up where the 54 is? It's got to be 30 or higher. 30 or higher. You ready to come take over in a minute, Nancy? You're good, huh? All right. So X, come on, pen. So X is 26 degrees, 34 minutes. All right, so what that means is I'm going to change my pencil to thinner because it's too thick to write it in there. So that means that this angle right here is 26 degrees, 34 minutes. This angle right here is 26 degrees, 34 minutes. This angle, and we've rounded this, just so you know, 26 degrees, 34 minutes. And this angle is 26 degrees, 34 minutes. All those angles are the same. Okay? So now I got to find what all those angles are from the positive x-axis like we did before. So the first one, you remember that theta and alpha are equal in the first quadrant? So the first one right here, the first one right there tells me that is my first answer in this problem. Okay? Then my second one goes from here over to that hypotenuse. We did this yesterday. What's the rule for finding the angle here? Finding this red arc angle in the second quadrant. Remember, this is 180 over here. 180 minus this. So it's 180 minus 26 degrees, 34 minutes. I did this yesterday, and I'm going to do it again today. You can do this on your calculator and DMS it again. Or you can do it by hand, which I'm going to do. I'm going to borrow 1 degree from this, and that makes me 60 minutes here. So 60 minus 34 is 26 minutes. 9 minus 6 is 3. 7 minus 2 is 5. So this next one that works is 153 degrees, 26 minutes. Question on that one? Okay, then I go comma. Now I got to find the next one. The next one goes from here all the way around to that hypotenuse. Does anybody remember the rule in the third quadrant? Can't hear you. What's the rule you do in the third quadrant? Remember, it's 100. You add the angle, right? You go 180 plus the reference angle. So now we got 180 plus the reference angle. So this comes out to be 34 minutes. 0 and 6 is 6. 8 and 2 is 10. Carry the 1. So the next one that works is 206 degrees, 34 minutes. Am I going too fast? Okay, last one. I got to go from here all the way around to that last hypotenuse. What's the rule in fourth quadrant? Anybody? 360 minus the reference angle. So again, I'm going to borrow 1 degree from the 360 so that I can subtract. So let's see, we got our 26 again. 9 minus 6 is 3. 5 minus 2 is 3. So the last one that works is 333 degrees, 26 minutes. I got some bad news for you. What did I do for all these answers? All these answers are what kind of answers? Okay, yeah, they're all positive. They're all between 0 and 360. But what did I do way back here when I found the reference angle 26 degrees, 34 minutes? What did I do to the actual angle? I rounded it. So guess what's true about all of those answers? See that answer right there, that 26 degrees, 33 minutes, 54.184 seconds? That is the closer to the exact answer. This decimal really keeps going. So since I rounded this answer, if I check these answers, guess what? They're going to be off a little bit. They should be close, but they're going to be off. So let's do one just to show you that they're off a little. Okay, so we're doing this one up here, right? Well, we don't have a cotangent button, do we? So what I'm gonna do is I'm gonna rewrite that real quick, and I'm gonna make that tangent to the fourth. So this means tangent to the fourth x should equal what? 1 over 16. Now it's going to be off. It's not going to be perfect, I'm telling you, because we rounded the answers, but I just want to show you, and I'm only doing the first one so you can see the first one. So the first one is at 26 degrees. We rounded 26 degrees, 34. You know what? I'm going to use that answer in there, actually. I'm going to use the one in my calculator first. So here's how you got to type this in. You got to go parenthesis, and then you hit tangent. And now here's what you can do to get that exact answer in there. You can go up and highlight it and hit enter, or you can hit second negative sign down at the bottom, and that will put that answer in there. Okay? And then I'm going to hit enter. Oh, I got to wait a second. I got to do another parenthesis, and that's to the fourth power, right? So I hit my caret, and I hit fourth power. That's how you got to write tangent to the fourth power. It goes outside. And I hit enter, and I'm going to get that number. Then I'm going to say, hey, that was supposed to be 1 divided by 16. I hit that number. See how those are the same? You with me? But when I put the answer, I round it in there. So again, I'm going to go up here. Oh, I can't do that because it's got an answer. Sorry. So I'm going to go tangent. Oops, I forgot my parenthesis. Parenthesis, tangent. And then we said it was 26 degrees. 34 minutes. Parenthesis to the fourth power, and this is rounded. So do you see how it's close to 0.0625, but it's at the extra crap out here? It's going to be close, but it won't be exact like the actual answer. Are we thumbs up what I'm telling you? So if you round an answer, it's not going to give you the exact answer on your calculator, but it should be really close. Should be really close. Okay, I'm done. So what we're going to do right now is I'm going to go, oh, I'm not done either. Yes, I am, because I already did this with you guys. All right, I'm going to shut off my video here.